Hello model engineers. Right, today I thought I'll try something a little bit different. I thought I'll try and make maybe one or two videos aimed at beginners, just explaining a few little techniques and talking about a few little bits of tooling and whatever. Just things I've sort of learned along the way, and the way I do things and the way I don't like doing it and whatever. And the videos will be very much aimed at beginners. Now, if you're an expert, if you've been doing this game a long time, well, this video isn't going to be for you. But if you're new to the game, and we're all new once, then I'll try and explain a few little things, like perhaps how to turn a flywheel and whatever. Now, these things, they're not rocket science, but if you've never done this thing before, then it's not always apparent. I know when I first started, I got a lot of help, as I say, turning flywheels and goodness knows whatever, and I'd kind of like to return the favour, as it were. Firstly, I thought what I'll do is talk about edge finding for drilling and milling and that kind of thing. It's something that crops up quite a lot with beginners, so it may be worth the edge somewhere. I don't know, about 15 minutes to talk about a few little things. Now I've got with me some of the tools I use. What I'll do is just have a little quick chat about them now for a couple of minutes here, and then I'll go over to the mill, pop these things in the mill, and demonstrate on a little piece of scrap how they work and the pros and cons of each method. So firstly, we've got this little kit here. Oh, just digressing firstly, sorry. It may be that one of the best ways of trying to figure out where to drill, etc., is nothing more than putting a bit of blue on your work, a little set square, scribing them and punching. Now, once you get reasonably good at it, you should be able to get within a few thou doing it like that. But of course there are better ways. If you haven't got one of these fellas, an automatic centre punch, get yourself one. They're only about £5 or £6 from most of the big hobby suppliers, and they're a brilliant piece of kit. I'll just quickly demonstrate how they work on this thing. I'll just put a centre pop mark on it. There we have a mark. It's just a kind of a spring-loaded affair that gives you an extra hand free, because you're not holding a hammer, and you're not needing to use a magnifying glass and goodness knows whatever. It's relatively easy to get it on the line and just press down. You can, of course, then centre punch it properly with a hammer if you want a bigger indentation. The other little thing that I recommend you get, if you haven't got one, is one of these, an odd-legged caliper. Excuse me, an odd-legged caliper, or a Jenny caliper, as sometimes referred to. These just help you draw a line parallel to the edge of something. So if we want to go parallel to that, probably a bit too much marking blue on there. It's not very good, that line, but you get the idea. I mean, if I was to redo it properly. It's not very good, but anyway, you know what I'm saying. It's quite a useful little piece of kit, is this. I use it quite a lot. It seems nowadays with modern technology that some of these kind of tools maybe are going a little bit out of fashion, but I still use them quite a lot. I like them. They do what they say on the tin, and there's no batteries, there's no to break down. They're alright. I mean, let's face it, 50 years ago every model engineer used these things, and there was some fantastic stuff built 50 years ago, just as there is today. Anyway, moving on to kind of centre finding, whatever. There's this little fella that I use, a wiggler set. We'll come on to that when I go over to the mill, but it's a little 5-piece set. The holder and 4 attachments. That's useful for finding edges. This thing is a similar kind of affair. It's got like the ends can run eccentric to the main body. You can probably see they're sort of hinged, well not hinged, but they're on like a little sort of I don't know, like a spring. They can move a few millimeters. And for round centre finding, I was going to say edge finding, centre finding on circular holes, edges, whatever, you need a different technique really. Now the way I do it is, I've got one of these little fellas, it's called a co-axial indicator. It's specifically for finding the edge, for finding the centres and edges of round objects. Quite a nice little kit. It's very accurate, and so we'll go over to the mill, we'll plug them all in and have a little play around for 20 minutes or so, and we'll see what we can do. Okay, I'll see you over at the mill. Right, we're now at the mill, which in my case is a little Chester Champion. It's a nice little hobby mill, does what I want to do. And I've got the wiggler set ready. Right, I can never remember which end goes. So we've got an attachment that fits in the chuck, and this little lever's on like a ball and socket swivel. We've got a parallel in the vise which will just serve as an edge that would represent our workpiece. So, hand titled out. So we've got the wiggler set in the chuck. Now I think they say that it wants to be running at about 500 RPM for the best effect, but I just fiddle about till I find what sort of signal's about right. So what it'll do, it'll start wandering all over the place, and you get it so that it's nearly running true. That'll do for what we want. Okay, so you probably can't quite tell from the camera angle, but I'm maybe about 10mm in front of the parallel, so we'll come in a bit closer. I'm now winding the table towards me. As I do so, once it starts touching, the ball should settle down into a smaller radius till it's running pretty much through. You can see now it's starting to settle down a bit because I'm touching it now. It's getting now so it's moving running through. Now what will happen, it'll get to the point where it's running pretty much dead straight, and the minute I go past that it'll spring out, or it should do. Let's see what happens. Nearly running through now. Bit further, just winding slowly. There you go. Now at that point where it starts to spring out, that's where I'm just starting to go past the edge. I'll do it again, I'll wind it back towards the body of the mill a bit. Do it a bit faster this time. So the minute it's about ready to spring out, you by trial and error, once you've played with it a few times, you get the hang, you know when it's just at that point where it's just about to spring out. That's when you need to zero your dial out, or set your DRO if you're posh like that. I'm not, I'm afraid. I'm still twiddling the old handles. Now, so far so good. That works. It does tell you when you're at the edge, but there is a snag. Now, the snag is that when it springs out, you're not actually, the mill spindle, the axis, isn't actually above the edge. What it is, it's above the edge plus half of the diameter of the ball, the radius of the ball in effect. Now, this little ball is 1/4 of an inch in diameter, 6.35 millimeters. So the radius, the half the diameter, is 3.175. So effectively, when it's you know, I'll show you like this. Effectively, when it's round the edge, you need to go past by another 3.175 millimeters, or 3.17 anyway, to get above the centre. Now, that isn't really a problem. It's not rocket science, but it does mean that every time you use it, you've got to factor in this 3.17. So you sort of zero your dial out, then you've got to add this 3.17 millimeters if you work in metric, of course, which becomes a bit of a bind. And if you're doing a lot of this, if you've got, I don't know, 20 different measurements to take, 20 edges to find, or something complicated, that means 20 times you've got to remember to factor in this 3.17. So although it isn't rocket science, it's prone to forgetting. You know, no matter how smart you are, occasionally you're going to forget. You'll either forget the 3.17, or you'll get a bit complacent doing it umpteen times, and you'll put in 3.07 or 3.11 or something. You'll put in a small error that probably doesn't look it at first, but once you start drilling your holes, you'll find it's in the wrong place. So I find that a bit of a snag with this, albeit it does work accurately. Though it's quite a nifty little tool, and it only costs about £5, I think, so it's well worth buying one. The other attachment I use quite a bit with this wiggler setup is the pointed probe that's used for finding centres, centre punch marks, etc. Let's pop that in. Now, assuming I wanted to find the centre to drill a hole, well, we'll use that one. That pop mark there, that centre punch mark that I made earlier. The hole's going to be deep enough. Yeah, it should be. If we wanted to drill our hole on that mark, what we can do is get close with my eye. Get the probe running through. As you can see, it's a little bit out at the moment. I'm going to say now that the point of it is running through. probably doesn't look it, but I think it is. It's probably within a thou anyway. So what we need to do is get that probe into the centre punch mark and still have it running through. So if I'll deliberately put it a little bit out for now. Yeah, I'm deliberately, the centre punch mark is to the right of the probe, so it should start kicking out a little bit or wobbling a bit. See how it's moving? Because I'm not on centre. So what I want is the probe to sit in that hole. That's still not true. Excuse me. Which is there. You can probably see now that I'm right on it. Yeah, that is above the hole. So if I was drilling the hole in there, obviously I would lock the table down. Try it again once the table has been locked down, because there can be a tendency with the table to just move a very small amount. Once you've got the table set down, locked down, and you're still on the punch mark, put your drill bit in, your centre drill, whatever, and drill through. That's pretty much self-explanatory. It also works actually just as good, just eyeing up on the cross without the centre punch. In fact, sometimes I would say it's better without the centre punch, but as the mark was there, I've used it. So that's a handy little thing. One thing you can do as a temporary measure, if you haven't got one of these, albeit they are only cheap little things, but I appreciate some people might be on a budget and this hobby can be expensive when you're first starting out. If you haven't got one, what you can do is a bit of a rough and ready thing. Put a little bit of plasticine on the chuck and a pin, like a sewing needle, a pin. You'll gradually get that running straight, you know, with a straight edge like I did with this. Get it running through, and that will give you an idea where you're going to drill. So it's kind of a useful little tip if, as I say, if you haven't got one of these, you got one on order or whatever. Okay. There are a couple of other probes in this little kit that's probably worth mentioning. I tend to only use the two I've just shown, but the other two, one of which is this one. It's a little cylindrical edge. I suspect it's probably about 1/16 of an inch diameter, bearing in mind this is an imperial set. Incidentally, I've never seen one of these in metric. I'd buy one if there was a metric one, but they all seem to be the same size in imperial. Anyway, I reckon that's probably about 1/16, and that's no doubt going to do pretty much what the ball attachment does. Never used it, and don't know if I ever will. Now the other one, the packet says it's an offset indicator holder. I don't know if you can see that. And to be honest, I haven't got a clue how you use it. It's obviously something to do with attaching a DTI to that and rotating it around. I guess it's something to do with finding the centre of circles, that sort of thing, centre of holes and around a circular object. I dare say if I fiddled about with it, I could probably figure out how to work it and whatever, but I say I've never used it. I've got other methods of finding the centres that I'll talk about later, so it's probably something I'm unlikely to use. But anyway, if anybody watching the video knows how to use it properly and can perhaps explain it, then by all means put it in the comments or answers on a postcard, please. I look forward to that. Okay, right, moving on, we have the next little gizmo, which is this edge finder. Now, this one kind of works on the same principle as the little wiggler set, but it's a slightly different construction. This one I see the advantage of being metric. It's a 10mm shank. The centre bit that's held is 10mm in diameter, and the little probe on the end is 4mm in diameter. So that is a little bit easier from a maths point of view. It kind of makes a bit more sense if you're working in metric. For that reason, I do quite like this one. It's perhaps a little bit fiddlier to use. Probably takes a little bit more practice to get good at it, but it does have that advantage of being metric. The other end is a point for finding punch marks, a centre for drilling and that sort of thing. And to some extent you can use it for finding the centre of small holes. I'll show that later. I don't think it's really intended for that, but occasionally I do use it for that. Okay, so the two ends are on kind of a spring, I suppose you'd call it. They can move eccentrically. Oh, there you can see there. They're probably got a couple of millimetres of offset that they can use. Now, the way you use it is we put it in our collared chuck, which, as I say, is a 10mm shank, so it's a 10mm collar, which means it can be a bit fiddly getting it in because it's a close fit. There we go. Let's just nip it up. Got our parallel back in the visors, our makeshift workpiece as it were. So you can see that this little thing, it's turning, or it will turn eccentrically. So the idea is similar to the wiggler. You close in on the edge of the work, get a bit closer. I'm probably about 2 or 3 millimetres in front of the work there. It'll run eccentrically, and gradually it should bring the two diameters, if you want to call it that, together, and they'll run concentrically. Then when you go past, like the wiggler, it should bounce out and read that you've gone past the edge. Now, it doesn't fling out like the wiggler. It does jump out a bit, but it's a little bit more subtle. As you can appreciate, it's only got a couple of millimetres of travel, so you sort of have to be a little bit, you have to be watching it a bit more. It's a bit subtle. Let's give it a try and see what happens. I think we'll turn the speed up a little bit. Okay, so I'll bring the work towards me and we'll watch how it gradually comes together and then jumps out. You can possibly see now it's gradually closer. Can't be far off being centred now. Turn it very slowly. Right there, you see it jump out a little bit. See how it won't stay centred because I've gone past. I'll try it again. One thing about this one, in my particular case, the way I've got my lighting set up, it gives a narrow strip of light reflection down the side that's closest to me, the right hand side, which you probably cannot see on the camera, and I have got an additional light for photographing. But ordinarily I can see the beam of light reflected, and when it's getting close I can see the two beams coming together, and I know when it's just about on the centre. In fact, what you can do is, when it's turning, if you run your finger or your fingernail along it, you can actually feel when it's running concentrically. Now that doesn't sound very accurate, but you need to bear in mind that a cigarette paper is reckoned to be about 1.5 thousandths thick, although I haven't measured it. And you can quite easily feel with your finger a lot less than the width, than the thickness of a cigarette paper. So your fingers are remarkably accurate. You know, you can feel, well, way less than 1,000th. You'd be surprised. So let's move the work out the way a little bit. So just by looking at the reflection that I was mentioning and using my fingernail, I can tell that that's running concentric, that is running true now, and that will be less than 1,000th of an inch out. Let's knock it out a little bit. Coming in on it now, zooming in on it. It's getting close now. Just by feeling it with my finger, I can tell when it's on. I've gone past there. Now I would say it's running true, and I'm just touching it now. Any further forward that I bring the workpiece will throw it out, so I'm now at the point where ordinarily I would zero the dial. See, I've gone past it now. Now, as I said earlier, this is a metric one, and that end is 4mm diameter, 2mm radius. So from that point of view alone, it is a little bit more intuitive to use. If you're working in metric, it's a lot easier to start adding 2mm onto your dimensions than 3.17. So it has got that little advantage. So what we'll do now, we'll have a look at the other end, the pointed end, which is useful for finding centre punch marks or perhaps just crosshairs on where. So we'll put that in. Give it a nibble. Right, I now have it turned round, so I've got the centre finding attachment in place. Now the idea of this one is, if I'm aiming for this centre punch here, which I'm nearly on, I want the point in that punch and the sides running concentrically. So let's first get the probe running nearly true. Close enough for what we want now. I'm probably near enough on it. Now I'm probably not far off the centre now, but it'll probably kick out a little bit and I'll be able to feel that it's not running through, because I don't think I'm quite on perfectly. See how it moved a bit there, because I'm not quite above the centre line. So what I need to do is get the point in the centre mark, and see how it's kicking out, and have it running concentrically, have it running parallel here. I think the table wants to go slightly away from me. A little bit better perhaps. You can see there, I'm not far out. It's moving slightly. See, I'm on it now. You can see when I lower the quill, the sides stay concentric. So at that point, I'm now above the centre punch mark. Obviously if I was going to drill me home now, I'd lock the table down, give it another try, just make sure it hasn't moved, because the chances are it will move a little bit. Swap the probe for a centre drill or whatever we're going to do, a mill or whatever, and away we go. The other thing I have found that you can do with this pointed probe, albeit I don't think it's necessarily meant to, is find the centre of small holes. Now, it's not 100% accurate, but if you want a quick means of finding the centre of a hole that with reasonably accurate with reasonably accurate results where it doesn't need to be absolutely spot on, then it will do the job. The shank, as I say, is 10mm in diameter, so the cone probably about 8mm at the top. So it will find that the centre of holes approximately up to about 6mm, 6 or 7mm in diameter. Now I won't go through the entire procedure because it's exactly the same as I've showed you with getting it to run through while it's in the hole, but I think you can see how it would roughly work. Gradually lower the probe in so you can get it going through. As I say, I don't think it's really intended for that, but it does work for semi-accurate results. Right, well that's the two cheap and cheerful ways of finding the edge of a work for milling or drilling or whatever. I had intended to talk about a coaxial indicator in the same video, but I think it's getting a bit too long, to be honest, so what I'm going to do is split this video into two, and then I'll make a separate video of the coaxial one probably tomorrow, and we'll call that part 2 of edge finding, centre finding, whatever. So we'll call it a day for that, and I might well see you tomorrow. Okay, thanks for now.